We want to look at some calculations in chemistry. I don't know whether you are among those that are having problems in calculating some questions in chemistry. Let me announce to you that the answer to your problem has just arrived. Anything that has to do with chemistry calculation, I want you to follow this page carefully. This is part 1, part 2. I'll make it as simple as possible. General formula for calculating moles, mass, volume, number of particles, and quantity of electricity through calculations involving electrolysis. I made it in stages. I will start from the first one, number of moles. Number 1, they say that N is equal to small m over big M. What is N? N simply means number of moles. What's big M? Big M means the atomic mass or the molecular mass. And most examinations, it is given to you. But even though if it's not given to you, you can still find it with this simple formula. As long as N is given to you and small m is given. What is small m? The small m there, or what I may call the lower m there, is the mass given or needed. Mass given or needed. So I would like you to take a look at this first part of this series carefully because it's fundamental. If you miss it, part 2, you may not get exactly what we are doing. Then next one is N is equal to CV. What's C? C is concentration of moles per dmq, or what you may call molar concentration. And then V is volume in dmq. Now before we go further, how do you identify this molar concentration? Let me add it here. One of the things you find out in molar conc is that the unit is normally written like this, mole per dmq. So anytime you see any value given to you and you have mole per dmq, without much ado, that particular value is the molar concentration, or what you call concentration in mole per dmq. The another formula for N is equal to volume per dmq over 22.4 dmq. This one is particularly for gases, not for liquid. For gases at STP only. So volume of a gas required or given, you are asked to calculate it in STP. Then in that question, you must be given this value, which is the molar volume of gases at STP, 22.4 dmq. Another one is calculating number of moles with regard to electrolysis, like I said. Quantity of electricity given or required. So, or electric current as the case may be. So you have Q is equal to 96500C, and I believe you know that 96500C is 1 Faraday. We will see these calculations and you understand better as we do the examples. Then number 5 is number of particles divided by 6.02 times 10 to the power 23. This is when you're looking for number of particles. That's when you're looking for number of moles, but you are giving number of particles and perhaps you are given this. That is what you call the Avogadro's number. With these two, you can find number of moles. Very interestingly, I want you to observe something here before we go further. Like I said, chemistry calculations is the easiest part of chemistry. Now, if you look at the number of moles, you observe that small m is on top. The one given is on top, but the standard, the atomic mass or the molecular mass is acting as the denominator or the divisor. Can you see that very clearly? And most cases, it is always given in exam. Then if you look at also the number of moles with regard to gases, you also observe that the molar volume, which is the standard molar volume for gases, is also a divisor or the denominator. The same thing with number of moles with regard to electrolysis. Observe also that the Faraday is the divisor, 1 Faraday, depending on the number of ions that are involved. We still solve that. Then look at also this case, the Avogadro's number is also the divisor, while the number of particles given is the numerator. So just look at the pattern, except for this one. You notice that These standards that are given are always the divisor. When you're solving number of moles, the standard are always the divisor. The standard here are always the divisor. Okay, now let's look at one of the SSCU questions. The question says, what is the amount in mole of sodium triisocarbonate 4 in 5.3 gram of the compound? And like I said, most often you're given the big M. That is the relative molecular mass. In this case, they gave you the what you may call the relative molecular mass of this particular substance, which is 106 gram per mole. Without much ado, it is so simple. You don't need to stress yourself. Just follow this page. As far as it's chemistry calculation, you find out that from this time onward, from today, as you're watching it now onwards, it becomes a child's play. Now, first of all, you have the big M. Always itemize what is given to you. It helps you to solve faster. 106 gram per mole. Then you also have the small m, the mass given, which is 5.3 gram. And you're looking for what? Small n, which is actually the number of moles, or what we may call the amount. Now, without much stress, you know that the best formula will be n is equals to small m over big M. Remember I told you that if you're looking for number of moles, the one given is always on top, and the divisor is always the standard, like the relative atomic mass, or molecular mass, or Avogadro's number, or Faraday, as the case may be. So what will I do now? I'll just say my n is equal to small m over what? Big M. So my n is equal to 5.3 gram all over 106 gram per mole. And if you divide that with your calculator, the answer definitely is going to be 0.05 mole. Now, let's look at another question that has to do with number of moles. What is the number of moles of oxygen that, let me add this, that contains 1.2 times 10 to the power 23 atoms of the gas? What number of moles that contains this number of atoms of the gas? Just remember the formula, that number of mole is equal to that one that is given, which is 1.2 times 10 raised to the power 23 divided by the constant, or the standard, which is called the Avogadro's number here, which is 6.02 times 10 raised to the power 23. Okay? Now, this one is so simple, you don't need to. If you use a calculator, that makes it very easy. Just say 1.2 exponential 23 divided by 6.02 exponential 22 divided by 6.22 times exponential 23. The answer will appear on your calculator. And what's the answer? It will give you 0.0199. That means you can approximate it to 0.02 moles. That's the answer to this simple chemistry question. Like I said, it's so simple. Just understand the format. The one given over the standard. That will give you the number of moles. Now, another simple question, still dealing on number of moles. We are laying foundation. Gradually, we move to more complex ones. Is what is the number of moles of 250 cm³ of oxygen at STP? Remember this word, STP, standard temperature and pressure. And what is involved here is gas. An examiner is wise enough to give you the molar volume of a gas at STP, which is 22.4 dm³. Very, very simple. You don't need to waste your time in exam hall. Just write. N is equal to the one that is volume given over the standard, which is 22.4 dm³. So that will give you that N is equal to, what's the volume given? 250 cm3 over what? 22.4 dm3. But notice something here. This one is in cm3 and it must be converted to what? dm3. So the wise thing to do is you multiply this 250 cm3 by 22.4 dm3. So this one, you convert it first to dm3 before your final solving. How do you do that? You now write 250 cm3 divided by 1,000. 250 divided by 1,000, converting to dm3. And if you divide that, definitely it is going to give you 0.250 dm3. 0.250 dm3. So that means in solving this now, this thing will now change. You now have it that N is equal to 0.250 divided by 22.4 dm3. 0.011 mole. That's the answer. That's the number of moles of this gas when it contains 250 cm3. So at STP, the number of moles will be 0.011.